Okay guys, so I did the same experiment that you did yesterday. This is from the one I set up on the side. I've got my mirror here and I drew round where my mirror was, and then I shone a ray of light onto it, and I had my light box over here and my ray of light shone along this path here. It hit the mirror and you could see where it bounced off, and I marked it on with pen the same as you have done. Now you did this 3, 4 or 5 times each, but I've only done it once just so you can see what you need to do. Now you will need to do this with each of your repeats of your experiment, because we are going to work out the angles of incidence and the angles of reflection for our line. Now the first thing we have to do is we have to start by working out where our normal line goes. Now the normal line is just an imaginary line that we draw at 90 degrees to where a beam of light hits a surface, or particularly hits a mirror and is reflected. So if I look at my results, my beam of light came along here, it hit the mirror here, so I need to draw my normal line going away from the mirror there. Now the normal line is drawn at 90 degrees to the mirror, so to do that I will need my protractor. I get my protractor, I place it so the cross of the protractor is where I've made this, where my two rays of light touch the mirror. So this is where the cross of my protractor is. I'll just see if I can zoom in. There we go. The cross of my protractor is where my 2 rays of light touch the mirror, and I placed it with this line of my protractor level with the front of the mirror. So I can measure from this line here, which is the mirror, all the way around 90 degrees, and put a mark where it says 90 degrees there, and so I can then draw a line going from my rays of light touch the mirror to that line, and we normally draw it dotty, so there's a little dotty line, and we call that our normal line. It's just an imaginary line, and if you can check, once you've drawn it, you can check it, mark your angle on. There's my normal line. Yep, that's 90 degrees away from the mirror. Now the 2 important angles you need, and I know some of you started looking at the angles yesterday, are actually this angle here and this angle here. Now the first angle up here is called the angle of incidence. Now the angle of incidence is the angle between the incoming ray of light and that imaginary normal line you drew at 90 degrees to where it hits the mirror. So the first thing you have to do is measure your angle of incidence. So we get our protractor, we put the cross where the ray of light hits the mirror, we put the 0, there you go, put the cross there, put the 0, and I'm going to use the inside part of the protractor for this. We put the 0 on where the incoming ray of light is, so and there's my 0. And then I measure round to where, what the angle is from here, round to my normal line. So if I count round, I've got, there's 10 degrees, carry on 20 degrees, carry on 30 degrees, and the line's just this side of 30 degrees, so I go up and it's about 2 little lines past it, so that angle there is 32 degrees. If I look at the other side now, I can measure the other angle which I've drawn in light blue. This angle is called our angle of reflection, and it's called the angle of reflection because it's the angle at which light bounced off of the mirror, reflection with an N on the end. So I have to measure this one as well. So I get my protractor again. I again place the cross in the middle of the protractor where the beams of light touch the mirror, and I move the 0 of my protractor round to the normal line, and I measure this time the angle between the normal line and the reflected ray. So I'm looking for this angle here. So if I have a look at my protractor, I'll have a look a bit more closely. A bit too close there. Right, here's my normal line. I'll make sure that's on the the zero's on that dotted line. Yes, it is. And I count round 10, 20. Oh, this time just under 30. That's where 30 would be. We're 1, 2, 3. So below it. So that's on my one is 27. Now I've only done mine very, very quickly, and I've not done mine very well. Your mirrors, of course, will have nice straight lines down them so that you'll get better lines than me. But that is how you work out the angle of incidence and the angle of reflection. What you need to do is work out the angle of incidence and the angle of reflection for each of your sets of lines, for each time you did the experiment. And you're going to draw for me in your books a little table that looks a bit like this, where you're going to have the angle of incidence, and then you're going to put the angle of reflection that matched it. So if I was doing my results, I would say the angle of incidence, let's have a look, what was it? The angle of incidence was 32 degrees. The angle of reflection that I got with mine was 27 degrees. Now, don't copy mine, because mine's not following the law of reflection, because I've only drawn mine really quickly. When you look at yours, you'll look at it, and hopefully, through looking at your results, you will uncover the law of reflection. Now, I hope that all made sense. I hope you all work hard today, and I look forward to seeing your work at the beginning of next week. Don't forget to make your musical instruments this weekend. Well done, guys. Goodbye.